Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at discrete probability distributions. So we're talking about discrete probability distributions of random variables. So a variable is something whose value can change. What makes it random is that the value it assumes is determined by chance. So random variables can be discrete or continuous. A discrete random variable has a countable number of possible values it assumes. Usually that means that the random variable can only take on certain values like whole numbers. But discrete random variables can't take on absolutely any value within a range. So what a probability distribution is, it's just a table or function that tells us how to calculate the probability of any value that it may assume. Now, in order that the distribution is valid, it needs to satisfy these 2 points. Probabilities need to add to 1 and no probability can be negative. So hopefully all of these concepts will become clearer in this example. So let's say I roll a normal 6-sided die. I'm going to let X be the number rolled. So X here is a random variable. X can take on values 1 to 6 inclusive. Which of these 6 values it assumes is down to chance. So that's why X is a random variable. So it's discrete because you can see there's only a small number of values that it can take. If there are only finitely many values that X can take, then of course this sample space is countable. The sample space contains only 6 possibilities, 6 values that X can assume. So the distribution of X is just going to be this table that tells us the probability of taking on any of these values. Now you know that when we roll a normal 6-sided die, the probability of rolling 1, 2, 3, it's a 1/6 for all of them. So this table constitutes a valid probability distribution because we can see if we add up all of these probabilities, we get 1 and none of them is negative. Let's look at calculating the mean and standard deviation of a random variable. So the mean, mu, is also known as the expected value. They're basically the same thing. It's basically a weighted average. Now, what this formula says here is that if you want to calculate the mean or expected value of a discrete random variable, you just multiply each outcome by its probability and add these up. So if I wanted to calculate the mean or expected value of our random variable from the previous slide, all I do is take each individual score, multiply by its probability. So I start with 1 and I times it by its probability. Then I take 2 and I multiply by its probability, and so on for all possible values X can take. And then after I've done this, I simply add up these numbers. So you can put this straight in your calculator. You actually get 3.5. So that is the mean or expected value when you roll a die. Now, of course, the expected value need not actually be a possible value. If you roll a die, you absolutely can't roll 3.5. What this means is, if I were to roll a die heaps and heaps of times, and I took the mean of all the scores, I would expect it to be 3.5. So it's what we expect the average to be after many trials. Now let's look at this formula here. This is how you calculate the variance of a random variable. And for shorthand, we write sigma squared. X is just letting us know that that's the random variable to which we are referring. So what we need to do to calculate the variance is calculate the expected value of X squared, then subtract the mean all squared. This is just what we calculated up here. So how do I calculate this part, the expected value of x squared? Well, I'm going to add to my table an extra row that has x squared values. So to get these, I simply square each of these numbers. So 1 squared is 1, goes down here. Then 2 squared is 4, down here. 3 squared, 4 squared, and so on. Now I'm going to calculate the value of x squared very similarly to how I calculated this. Here, I'm just going to take each of these x squared values and multiply by the probability. So again, I have 1 times 1 over 6. The next one will be 4 times 1 over 6. And then I have 9 times 1 over 6, and so on. So once again, after I've done that, I need to add up each of these. And you can use a calculator, you get 91 over 6. So this number here always has to be more than that number there. The variance is always positive. If you get a negative answer, you've done something wrong. So here, the variance of our random variable x is just this number, which is e of x squared, minus this number squared. That's that part. And so putting this in our calculator, we get 35 over 12, 2.916 recurring. So that's the variance. Now this here says the standard deviation of x. The standard deviation is just the square root of the variance. So the standard deviation here is just going to be the square root of what we just found for the variance. Square root of 35 over 12. And putting that on our calculator, we get about 1.71. So this is another reason the variance has to be positive, because we're square rooting it to find the standard deviation, and we can't square root a negative number. So remember, the standard deviation is supposed to tell us the average distance from the mean, in this case 3.5. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.